Welcome back to finding missing angles, missing sides, and bearings using the sine and cosine rule. If we read this word problem here, which we actually tackled and discussed previously in two videos. The first video, I displayed the problem. In the second video, I displayed the drawing of the problem. Today, we are going to fully solve this problem together. A hedgehog wishes to cross a road without being run over. As we're reading the word problem, we must be drawing the diagram so that we can place all the given numbers on this diagram. He observes the angle of elevation of a lamp post on the other side of the road to be 27 degrees from the edge of the road. So, we're going to start. This is our lamp post, and the angle of elevation, if we're observing this lamp stamp from this point haphazardly, because they didn't tell me this distance, and so this is my 27 degrees that is given to me in the question, and then from this point, he went back 10 meters as following, and he is still observing this lamp post. So this new angle when he went back 10 meters is 15 degrees. So this is my 15. How wide is the road if he can run at 1 meter per second? Now, as we got the drawing ready here, we can start finding missing sides and missing angles. So, if we name this one as A, the opposite side, which is the height of this lamp, the opposite side to angle A, which is the height of the lamp, we're going to call it as A small. The lamp always makes 90 degrees with the ground floor. So this angle here is definitely 90 degrees. If I name it as B, so it's going to be 90 degrees. We're talking about this right angle triangle, the small one we have in here. And the opposite side to angle B is this hypotenuse here, which is B small. This angle here is C, which is 63. How did I figure out the 63? We added the 27 and the 90, and we subtracted the sum from 180 because angles in a triangle add up to 180. So, the opposite side to angle C is C small, which is unknown, right? Now, if we go to the other triangle, which is this one here, not the right angle, the other triangle here, as you can see. If we name this as M, which is 15 degrees, that is given to me in the question, and the opposite side to M is actually the side B. So side B is equal to side M because this is a common side between the two triangles. Now, angle N. How can we figure angle N? Angle N and angle A, they are on a straight line. So angle N and angle A add up to 180. So if we subtract the 27 from 180, we're going to find N as 153 degrees. Can we figure out this small angle here? Before we figure out this angle, the opposite side to angle N is this side, which is N small. Now, this small angle here, like we said, in this triangle that I'm pointing at with my cursor, angles in a triangle add up to 180. So if we add the 153 and the 15 and we subtract the total from 180, we're going to figure out as angle Q equals to 12 degrees. Now, immediately after I identify the angle, we must identify the opposite side. So this is angle Q. The opposite side to angle Q is the 10 meter. So the 10 meter is equal to Q. Now that I identified each angle and the opposite side to each angle, I can start using the sine and cosine rule to figure out the unknowns. So, if we start with triangle MNQ, this triangle MNQ, to calculate the length of side M, which is the common side between the two triangles. Okay? So, Q is known as 10 and angle Q is known. So, Q over sine angle Q is equal to M, which is my unknown, and angle M is known, over sine angle M. Let's substitute in this rule. So, Q is equal to 10, as we can see here in the diagram. 10 over sine Q, angle Q is equal to 12. So, sine of 12 degrees is equal to M is my unknown over sine angle M, and angle M is equal to 15 degrees. So, sine of 15. Now, as you can see, the reason of having these arrows is always if you're working vertically, keep the equal sign underneath each other. Have yourself organized as you're working out your steps. Now, let's cross multiply. So, when we cross multiply, M is my unknown. So, you write M is equal to and fraction line. What is my M multiplied by? It's multiplied by sine 12 degrees. So, sine 12 degrees is my denominator. And the other two numbers, they go up to the numerator multiplied by each other, which is as following. M is my unknown equals to fraction line. M is multiplied by sine 12, so sine 12 degrees goes down. And the other two numbers, they go up multiplied by each other. So it's 10 times sine 15 degrees. Now this part is ready to be inserted in the calculator. And you will find M as 12.4 correct to 3 significant figures, because you stop at the first 4 after the decimal, because 1 is your first figure, 2 is your second, 4 is your third. Look at the right of the 4. 4 is less than 5, so it's not going to bring my 4 up. So now, once you find M, it means that you found B as well. So place what you found on the diagram immediately, as you can see here, so that you can find out, or you can see directly what is it that you found and what is it that is still missing. Okay? Now, we're gonna go to the second triangle. So, if we go to triangle ABC, and to calculate the length of side M, we're not calculating the length of side M here. Sorry, this is by mistake. We're going to calculate side C, as you can see, because we already found side M and B, which are equal, right? The missing side here is C, so we're trying to find C. All right, so side B, which we have already found right now, over sine angle B, which is 90 degrees, is equal to side C, which is my unknown, over sine of angle C, which is known, and it's 63 degrees. Let's substitute here. So B is 12.4 over sine 90, because B is equal to 90 degrees. C over sine C capital, which is 63. Let's cross multiply. C is my unknown, equals to fraction line. C is multiplied by sine 90. So sine 90 degrees is my denominator. And what goes up to the numerator? 12.4 times sine of 63 degrees, which is going to be as following. Now, this left side is ready to be inserted in the calculator. So we're going to calculate side C, which is going to be 11.1. This is correct to 3 significant figures. The first one on your left is your first figure. The second one is your second figure, and 0 is my third. So I'm going to stop at 0. Look at the right. 9 is greater than 5, so it's going to bring my 0 up to 1. So 11.1 meter is the length of side C, and this is correct to 3 significant figures. Now that I found C, place what you found directly on the diagram. So again, get yourself organized. Always place what you found on the diagram so that you know what you still have missing to work it out. Now, if we if we read the question once again, here they asked how wide is the road. So this is the width of the road, which is C. So it's 11.1, right? How wide is the road? And then let's carry on. If he can run at 1 meter per second, 1 meter per second represents the speed. How long will he take to cross? How long? It means he needs the time. The general rule of speed, distance, and time, speed is equal to distance over time. Now, since he's asking in the question for how long, then it's asking for the time, then let's rewrite this general rule in terms of t, meaning let's make t the subject. Make t the subject. So we're going to multiply, get rid of the denominator, which is t, by multiplying all by t. So t times s will be equal to d. We're isolating t, we're making t the subject. So we're going to divide all by s. So t is equal to d over s. Now let's substitute in t. d is 11.1 over the speed that is given to me in the question, which is 1 meter per second. So the time will be 11.09170,229, and it's in seconds. And if we want to write it correct to 3 significant figures, it's going to be 11.1. Now, the last part of the question, if cars are traveling at 20 meters per second, how far apart must they be if he is to survive? So, let's organize the information that is given to me in the question. They gave me the speed one time here, and then they changed the speed to 20 meters per second. So, the speed, and we figured out the distance between the two roads. So, we have the distance as well, okay? And now he's asking how far apart must they be, okay? So when the speed was 1 meter per second, the distance, the given distance is 11.1. When the speed is 20 meters per second, so the distance here is missing, right? Let's cross multiply. And when we cross multiply, it's 11.091 times 20 and 1 times the unknown. So question mark, which is my unknown, is equal to and fraction line. What is my unknown multiplied by? By 1. So the 1 will go down as my denominator and the other two numbers will go up as numerators multiplied by each other as following. This part is ready to be inserted in the calculator and the final answer correct to 3 significant figures will be 222 meters. So they must be 222 meters apart for him to survive if the car is traveling at 20 meters per second. Now, let's have a look at this question here. This is a 3D object. This is a 3D object, yet the sine and cosine rule can still be applied on 3D objects. The secret is we need to look and to find triangles. We need to take each side of this 3D object on its own and calculate the angles or the missing sides accordingly. For example, in the cuboid here, we call this cuboid or rectangular prism. Find WY, so WY, the length of side WY, meaning I have to take the ground floor here or the face that is sitting on the ground to deal with WY. And they're asking for DY, so DY, the length of side DY. So I must take the right side of this cuboid or the right face of this cuboid to deal with it to find the length of dy. And WD, so WD, I must take the back face or the back side, which is WADZ, in order for me to calculate WD. And at last, they want angle WDY. So I must take this part here. Let's tackle the problem step by step. So WY, like I said, WY, I must take the ground floor or the face that is sitting on the ground, which is as following, right? So this is a rectangle. If you build this cuboid, the face that is sitting on the floor is a rectangle. And WY is the diagonal that which is the distance between the two opposite points. W and Y are the opposite points, and the diagonal connects these two opposite points together. Okay, so this is a rectangle. So this one here, which is WYX or WXY, is a right angle triangle. Am I right? A right angle triangle, as you can see here. Two sides. So the diagonal WY in the right angle triangle is actually the hypotenuse. So WY, the length of WY represents the hypotenuse in this right angle triangle. Fine. Can I apply here the rule of Pythagorean theorem, which states, so this is the horizontal side and this is the vertical side, and the Pythagorean theorem states hypotenuse to the power of 2 is equal to the horizontal side to the power of 2 plus the vertical side to the power of 2. Let's substitute here. So the hypotenuse is WY squared is equal to, the horizontal is 8, so 8 squared plus the vertical is 6 plus 6 squared. Square root each side because we are trying to find the length of WY only and not W squared. So WY is square root of 8 squared plus 6 squared. This right side here can be inserted in the calculator, and if you do so, you're gonna end up with WY is equal to 10 meter. Can you please try applying the cosine rule of finding the length of WY and figure out if it works or not? Now, let's go to the second part, which is DY. DY, we're going to take the right side, as you can see here. And again, the right side, if you build this cuboid, is also a rectangle. And DY is the diagonal. It connects D and the opposite point to D is Y. So the diagonal connects the two opposite points together. And if you go to DZY or YZD, this is a right angle triangle, as you can see. If this is 6, YZ is 6, then ZD, which is parallel to CY, is actually equal to 5 meter. So again, the horizontal and the vertical sides are known and the hypotenuse is unknown. So can we once again apply the Pythagorean theorem? DY is the hypotenuse, like I mentioned, and this is the horizontal, this is the vertical. Let's apply the Pythagorean. Hypotenuse to the power of 2 is equal to the horizontal side to the power of 2 plus the vertical side to the power of 2. Let's substitute. The hypotenuse is DY squared is equal, the horizontal side is 6, so 6 squared plus vertical side is 5, so 5 to the power of 2. Let's square root each side because we're calculating DY and not DY squared. So DY is equal to square root of 6 to the power of 2 plus 5 to the power of 2. This right side is ready to be inserted in the calculator, and if you do so, you're going to end up with DY is equal to 7.81 meter if the answer is requested to be placed as 3 significant figures. And once again, I would like you to try using the cosine rule to find the unknown side DY and figure out yourself if it works or not. Now, let's go to the third part of the question, which is WD. And in order to figure out WD, we must take the back side of this cuboid. And this is the back side. And it is a rectangle as well. And WD is actually the diagonal in this rectangle. And WZD or DZW is a right angle triangle, as you can see here. And this is 8 meter because XY is parallel to WZ. So WZ is equal to XY, which is 8. And again, DZ is parallel to CY. So if they're parallel and equal. So DZ is actually equal to 5. So 8M is the horizontal side, 5 is the vertical side. And WD is the hypotenuse. Let's once again apply the Pythagorean theorem. And let's substitute in this Pythagorean theorem. So the hypotenuse is dw squared is equal, the horizontal side is 8 squared plus the vertical side is 5 squared, and we're finding dw, so square root each side, so dw is square root of 8 squared plus 5 squared. Insert this in the calculator and find dw as 9.43 meter, correct to 3 significant figures. Last part, so we must take triangle WDY, as you can see here. Okay, now we found in the previous steps the lengths of WY, WD, and DY. So WY we found it in the first step as 10. DW we found it in the second step, which is 7.81, and at last in the last step we found WD. So we have 3 known sides. Let's have and they're asking for angle WDY. If I name this angle here as D degree, the opposite side to angle D capital is equal to D small, which is the 10 meter. And if I name this as Y capital, angle Y capital, the opposite side is the 9.4. And if I name this one as W capital, the opposite side is the 7.81. Now, use the cosine rule to find the, not the length, to find the size of angle YDW. So, D squared is equal, what are the other two sides? W and Y. Y squared plus W squared minus, in brackets, 2 times Y times W times cosine of D, of angle D capital. Okay, I just wanted to make it a little bit bigger here so that we can work it out. Okay, so let's substitute here now. D is 10. 10 to the power of 2 is equal to, Y is equal to 9.43. So all to the power of 2 plus W is equal to 7.81. All to the power of 2 minus, in brackets, 2 times, again, Y is 9.43 times W is 7.8 times cosine D, which is my unknown. Let's simplify this one. So 100 is equal to, this one, if you take it to the power of 2, it will be 89, and 7.81 to the power of 2, it will be 61. And if you multiply 2 times 9.43 times 7.81, it will end up to 147.4 times cosine D. Let's simplify further. 100, if we simplify it further here, 89 plus 61 is going to be 150. Let's solve the equation because we are trying to find D. So we're going to start, we keep what's inside the bracket. We're gonna get rid of the 150 at first. So subtract 150 from both sides of the equation. So 100 minus 150, it will be minus 50. Here it means minus 147.4 times cosine D. So we're gonna get rid of minus 147.36. But we're not going to add it on both sides of the equation. We're going to divide, because the relation between the 147 and cosine D is multiplication, and we solve by applying opposite operation. So divide all by negative 147.3634962. So, negative 50 over negative 147.36 is equal to cosine D. So, we are again solving for D. So, we must isolate D. So, we're going to apply the cosine inverse on both sides of the equation. So, cosine inverse of negative 50 over negative 147.3634962 is equal to D. Now, this is ready to be inserted in the calculator, and we're going to find D as 70.16594,746 degrees. Please think of this question and try to apply the sine and cosine rule, and don't forget your basics, the Pythagorean theorem as well, to calculate the missing sides or angles in here. Thank you so much for watching. Please watch this video a couple of times if you struggle with any of the steps at solving this problem, and I'm going to see you in the next video.